In this video, we're going to take a look at the relationship between the derivative of an inverse function and the derivative of the original function. So we have this theorem that makes this statement. If f of x is differentiable and it has an inverse function, call it f inverse of x, then f inverse of x is itself differentiable at all values of x for which f prime of f inverse of x does not equal 0, and we have this relationship. So the derivative of the inverse function at x is 1 over the derivative of f evaluated at f inverse of x. Sounds a little confusing, but we'll make sense of it here with an example. Let's take a look at the proof of this first, and then we'll look at this example. So to prove this, we start out with this fact. Right? That's true for a function and its inverse function. F of f inverse of x gives you back x again. So now what we're going to do is differentiate both sides here, and we get this. Okay, so I just applied the derivative. Now this side here, of course, is equal to 1. Now for this side here, we're going to have to use the chain rule. So we're going to have to think of this term right here as being a u. So we're going to differentiate this with respect to u and then multiply by du dx. So what we get is this. Now keep in mind, the u is f inverse, so I'm going to put that in place of the u, and what we get is this. So here, this piece right here, this is just a rewrite of this term right here. d du of f of u is f prime of u. The u is f inverse of x, remember. And this piece right here is just the du dx. And now all we have to do is divide this to the other side and we get our result. So just taking this, dividing it underneath the 1, leaving this on the other side, we end up with our result right here. So we end up with and that's exactly what we have written up here. Now let's take a look at this example, and we'll also illustrate this example graphically to make more sense of this. So if you recall from a previous video, we looked at this function, f of x equals x squared minus 2x plus 3, for x that should be greater than or equal to 1. And we found that its inverse function was given by this, 1 plus the square root of x minus 2. So you can go back in the previous video for inverse functions and see how to do this. You can just take it for granted that this is the inverse function for x squared minus 2x plus 3 with this restriction on its domain. So let's verify these two things here. Let's verify that the derivative of this, the inverse function at 3, is 1 over f prime of f inverse of 3. So we're going to evaluate both of these and show that they're equal. So if I have that f inverse is given by, then note that the derivative of this, that's going to be so there's my derivative of f inverse, and we have to evaluate the derivative of f, so let's also note that so there's my derivative of f. And let's also note that f inverse of 3, if I put 3 in here for x, I get 1 plus the square root of 1, and that is just 2. And so f of 2, let's also note f of 2 is, it should be 3, right? If f inverse of 3 is 2, then f of 2 should be 3. And if I put 2 up in here for x and for f, notice I get 4 minus 4 plus 3. Yes, I do get back 3. Okay, now with all of this noted, let's verify part 1 here. So notice then that the derivative, so if I plug 3 in here for x, I get 1 over 2 times the square root of 1. That's going to be 1/2. And if we evaluate this part, let's see, f inverse of 3 is 2, so I'm going to get, and if I put 2 in here for x into the derivative of f, I get 4 minus 2. That's going to be, so that's going to be 1/2 then. And yes, these are equal. And that verifies this part right here. Now let's verify this down here. This is just for general x. Instead of putting the number 3 in, we just want to verify this for any x, which is the same as this up here. So we just want to verify this is true for these two functions for any value of x. So for part B, let's see, the left-hand side here, we already have that written out. That's this piece right here. So just note that. And then we have to evaluate the right-hand side here, this piece. So f prime, or 1 over, well, let's see, f prime is 2x minus 2, so this is going to be 2 times f inverse minus 2. You see I just substituted the this piece right here in for the x down here. And now we have to evaluate this and verify it's equal to this. And let's see, f inverse was what? It's this right here, right? So it's going to be, and then distributing this 2, we get, oops, and that should be a minus 2. And now we see these 2's cancel, and we do get this up here. So we do indeed get, and we see that these 2 here are equal to each other. And that's what we wanted to verify. You see, so we have the left-hand side, this piece is right here. And then we evaluated the right-hand side, and we found that they are indeed equal to each other. Now let's take a look at a graphic that illustrates part 1 for us. So here we have a graphic illustrating part 1 of the previous example. So right here, this curve is the graph of x squared minus 2x plus 3. And this curve right here is the graph of the inverse function, 1 plus the square root of x minus 2. Now right here we have a point 3, 2 on the graph of the inverse. And then moving across the main diagonal an equal distance, we have the point 2, 3 on the graph of the original function. And so working through our example, we found that the derivative of f inverse of 3 was 1 over f prime of f inverse of 3, and that turned out to be 1/2. Okay, so the slope of this line right here, the tangent line right here, that slope is 1/2. And the slope of this line right here, this tangent line right here, well, if I take the derivative of this function f prime, of course that's 2x minus 2, and I evaluate f prime of 2, I get back 2. So the slope of this line right here is 2. So graphically what that theorem is saying is the slope of the tangent line right here is 1 over the slope of this tangent line. So if you move an equal distance across the main diagonal, you hit the graph of your original function, and the slope of this line right here is 1 over the slope of this line, this tangent line on the graph of the original function over here. So that's graphically what part 1 is telling us. And that concludes this video of the derivative of an inverse function in relation to the derivative of the original function.